How does that work? Well, integration by parts tells you the integral of u dv is equals to u v minus the integral of v du. So basically, you just memorize it that it's v on the other, it's dv on the other side, and it's gonna be du on the other side. So what does this mean actually? You have to like analyze a dv in whatever the case. I'm just gonna do that with x ln x. So if it does not work with substitution, it's basically integration by parts. Some other complicated cases result in both by parts, and then you can then apply substitution. Other cases require you to do by parts twice or 3 times, depending on the degree of your case. And then notice that you have x ln x dx. From this, you must analyze u, and you must analyze dv in this case. If you fail to analyze that, you are out. Okay, look at this thing. What derivative do you know? What can you be able to derivate? We can be able to derivate both x and ln x, okay? And then what can we be able to integrate? Okay, I don't know about you, but I don't know about the integral of natural log of x, so I'm just going to stay away from that. So I can be able to integrate x. So if you cannot integrate the other one, but you can integrate this one, then let that be your dv. Let what you can integrate be dv. So in this case, I'm just gonna rearrange this. So I'm gonna have ln x from the start. So I'll have ln x multiplied by x dx. Now that it's in my formula, I know that u is equals to ln x, and dv is the rest of that. Dv is the rest of that. So now, you're gonna apply the formula now. So the formula tells you that you're gonna have u. Okay, in the test, you have to like show all steps. You must be able to show your u, and you must be able to write your dv. dv in this case is x, and u is ln x in this case. So you must be able to like show that. So now, what's the derivative of the natural log of x? The derivative of the natural log of x is going to be 1 over x. So you have 1 over x dx as the last term of that, the derivative of that. So you already know what's inside the integral of the other side. And then you integrate x. Remember, you derivate ln x, you get 1 over x. Now you integrate x. The integral of x is going to be 1 over 2 multiplied by x squared, or x squared over 2. X squared over 2 or a half multiplied by x squared is the same thing. Remember, I'm just basically following this formula. Now what's u? That's ln x. What's the integral of x? It's half x squared. So I can just do this. I can have the x squared. I'm just going to put the x squared in front. It still doesn't matter. I'm just doing it so you don't confuse this x with this other one. So that's why. So I'm going to have something like this. Then you're going to do that. You're going to proceed with that. Then you'll have x squared, the natural log of x, divided by 2. Then you subtract. You can put the half outside, properties of integration, and then x squared divided by x, that's x, and then you have dx of that. So if you further proceed with this one, you're going to get x squared, the natural log of x, divided by 2 minus half. Now the integral of x is going to be half x squared, or x squared over 2. Then don't forget to add your constant when you are done with integrating everything. So if you further simplify this, it's going to be x squared ln x divided by 2 minus x squared divided by 4. And then you add your constant there. So where do you do by parts? Where substitution fails. Remember, the equation by parts, it's integral of u dv is the same as uv minus the integral of of v du. So that's just the formula that you're familiar with. So now I'm trying to integrate ln x. Now this is the same as ln x multiplied by 1 dx. Now let this be u, let this be dv. So from the formula, you're gonna have ln x, the integral of 1, which is remember this is dv. The integral of 1 is gonna be x. So you'll have x. I'm gonna put the x in front so you don't confuse it with this one. But the order doesn't really matter. I'm just gonna do that because if I put x, you'll just consider it as if it's in the ln. So I'm just gonna put it outside to avoid confusion. Now you're gonna subtract the integral of. Now you're gonna have the integral of this, which is x, and du in this case will be the derivative of this. It's gonna be the derivative of ln x. The derivative of ln x, it's 1 over x dx. Show that. Then so if you further continue with this, you're gonna have x ln x minus x times 1 over x, that's 1. So you're gonna have the integral of 1 dx. So what's the integral of 1? So the integral of 1 is gonna be the same as x. So don't forget to add your constant when done. So this is how powerful integration by parts is. You use it if substitution fails, or if no substitution works in whatever you'll be integrating. So let me just do one last bit of problem that requires by parts. Let me just do the integral of let's say arctan x dx. So let's say integrating arctan x. We know that there's no derivative that gives you that, and if you try to make substitution here, you'll end up having to have a problem with working that integral. So I'm going to use substitution. So this is the same as the integral of arctan x. Since I cannot integrate arctan x, then I'm just going to put 1 there and have something like this. Remember, arctan x is the same as arctan x times 1. It's basically the same thing. So I haven't really changed anything. So this is my u and this is my dv. So now you're going to have u, which is arctan x. Then what's the integral of 1? It's x. I'm going to put it up front so you don't confuse it with this. It's basically what I do in most cases, so you don't end up confusing it with this one, because some people might think it's arctan x squared, of it, which it's not. So then you subtract the integral of v, in this case it's x, and now you derivate arctan x. You're gonna have 1 over x squared plus 1, then dx. So now you have x arctan x minus the integral of x over x squared plus 1 dx. So I'm just gonna multiply the inside and the outside by 2. By half, I mean. So since that 2.5 will cancel, so it's basically I haven't really changed anything. I'm just gonna put this. Now what does this remind you of? Think of natural log, for example. So that means substitution. Yeah, you did it by parts. Now you're gonna do it by substitution here. Let x squared, let u equals x squared plus 1. Then du is equals to 2x dx. Then dx is du divided by 2x. So you're going to work on that. So this integral further proceeds to x arctan x minus half into the integral of 2x divided by u multiplied by du over 2x. Then the 2x will cancel, and then you'll have x arctan x minus half. Then you'll be left with 1 over u. What's the integral? Let me just write it down. 1 over u du. So you have something like this. Now you're gonna have x arctan x. You're gonna have x arctan x minus half. What's this? The natural log of the absolute value of u plus a constant. Since you're done integrating, don't forget to add that constant. It's pretty much important. So you're gonna have x arctan x minus half the natural log of what's u is gonna be x squared plus 1. But since x squared plus 1 it's always positive, you can remove the absolute values. So it's x squared plus 1, then you add that constant there. So this is integration by parts, but this one was funny. It was a bit impressive because it wants you to do it by parts and then do it by substitution, and then you arrive to the answer. Hopefully, I hope you learn something from this. Thanks for watching, and practice more problems on integration by parts, and see if you can work it out. Okay. Here's something you can try. The integral of x multiplied by e to the x dx. Try to see if you can do it by parts. Thanks for watching. Don't forget to share and subscribe, and keep on practicing. It will pay off.